There's a new zero-day attack that's taking place on the Java runtime environment that's gotten a lot of attention recently. Not that I would describe that attack in this video. So first of all, if you don't know, a zero-day attack, or zero-day vulnerability rather, is one in which the actual exploit code existed in the wild before anyone even knew that there was a vulnerability in the first place. And in this particular case, the exploit code for this vulnerability is implemented inside of a Java applet. Okay, a Java applet. And how do applets work? Well, normally when you surf the web, and let's say you have a web browser and you're surfing the web and you go to a particular website, that website, if it contains an applet, will load that applet, and that applet basically represents, let's give it, let's see, www.something.com. Let's say you go to a particular website. And that applet basically represents a small piece of software that gets executed in the context or within your web browser or your web browsing environment. Now, Java has what's called a sandbox environment. It's got a sandbox. And what Java basically does is it'll actually monitor the runtime, the actual execution of code within the applet, and it'll examine that code for anything that might be nefarious, and it won't, for example, allow that code to do anything outside of the sandbox environment. So, for example, this applet is trying to, let's say, do something that involves right into your local file system. That'll typically get blocked by the sandbox because it'll the runtime environment will basically monitor what calls are being made within this applet, and it'll prevent that applet from doing anything that it shouldn't be doing. Okay. Now, this vulnerability, CVE 2012-4681, manages to circumvent these existing security measures, and I think it's quite remarkable in how it does it. And really, at its core, what it's basically doing is it's taking advantage of the fact that the Java runtime environment can be tricked into changing its own security settings. And normally, an applet would not be allowed to make such changes, and certainly any attempt to do so would be flagged, as bad. But the exploit's authors actually found a way to bypass these security checks. Let me actually describe how that works, and I'll show you some of the exploit code right here. So here's the exploit code, and really, when the applet's called, the applet has something called an init function. So let's kind of write that down, init. And really, the init function is what sort of kicks things off. And at some point, the init function calls this method here called disable security, which, as you can imagine, tries to disable security. This is a user-defined function within the applet. And the first thing that disable security does is it creates a new security manager right here in this particular line of code. It creates a new security manager. And this security manager is configured to give the applet permissions to do things like read, write, and execute files on the local file system. So you can see where the permissions are being set. Okay. Now at this point, the security manager is now, I guess, configured in a way that the attacker would like, but he still has to trick the Java runtime environment into actually using this rogue or this somewhat selective security manager in what's called the access control context, or ACC. And you'll see the access control context listed here and also listed here as well. Okay. Now, the next thing that disable security does is it calls a user-defined function called setField. So here's a setField right here. And setField is really the method that does all the heavy lifting, and really through a series of steps, it tricks the system into supplanting the existing security manager in the access control context with the rogue one. All right, so how does that work? So normally the access control context itself is a private field values. It's not something that you should be able to access unless you're a privileged, unless you're running in actually just in general, you shouldn't really be able to access it. But what effectively happens is that, and this is really where this method down here, this sun.awt.sunToolkit, comes into play. And this particular method, basically, or this class rather, contains a method called getField. So there's a method inside of this sun.awt.sunToolkit class called getField, and really it turns out you can within get field, there's something known as a do privileged block, Okay, and basically, the you can manipulate how get field is called, and really to do that appropriately, you can basically, it turns out, I guess rather maybe when done appropriately, you can access and modify the access control context within get field. Okay, and really this is the point at which we're basically calling, through the use of this execute method in local expression, we're basically able to modify, we're able to get field to kind of do what we want instead of a do privilege block. And really that results in swapping out the existing access control context with the attacker's version. And once the attacker obtains the, I guess, privileged access that it wants to the local file system, it can now effectively sidestep the existing security mechanisms that Java provides. And the attacker can now potentially download new code onto the local file system. Okay, and the real key here, and this is kind of the high level, what's being manipulated, you see these statement, these executes and these statements here. And through the use of execute and expression methods and statement methods, and let me actually kind of highlight where some of these are. So it's an expression method here, and there is an execute method here, and statement methods as well. And it turns out through these statement methods and through these expression methods and through executing the contents that have been created within these statements and expressions, the attacker is able to basically trick the Java runtime environment into allowing its own access control context to be swapped into or placed into or replaced the existing one. Hopefully that made some sense. I realize it's a bit of a high-level description, but I think it goes to show that that when you have programming languages of any sort, especially in web environments that are fairly complex and somewhat sophisticated security models, attackers can often find ways to sidestep those security models and sidestep those sandboxes through a clever use of the functionality provided by the actual environment.